Okay, let's go ahead and begin. I'm going to turn it over to our CIO, Chris Bradley, so he can give you an overview of Protect Services Group before we begin.
Great, thanks, Oakley. Joe, could you go to the next slide, please? So good afternoon and welcome to our webinar on auditing data access in your Microsoft SQL Server. As Oakley mentioned, my name is Chris Bradley. I'm the VP and CIO here at Protect. And before we dive into today's topic, I want to take a moment to introduce Protect to those of you who may not already be familiar with us. Protect Services Group is a technology services firm with 29 years of experience focused on understanding the technology needs of businesses and applying a range of innovative solutions designed to help drive them forward. With a wide range of services and solutions, some of our core areas of expertise include managed services ranging from fully outsourced IT operations to custom services designed to meet specific customer needs, cloud solutions from infrastructure as a service from large public cloud providers such as AWS and Azure to enterprise cloud and a variety of SaaS solutions. Security solutions, including our managed security stack, utilizing a layered approach to protecting IT and data assets, security assessments, compliance SIM and SOC services, and security awareness training and testing. Carrier and voice services, providing consultative analysis and cost optimization for internet and telecom services, premise-based phone systems, and cloud-hosted voice and call center solutions. Technology and consulting services, which range from small to large-scale IT projects to consultative engagements in any of our areas of expertise. Talent acquisition, with a full-featured staffing division, we are able to assist with temporary and permanent placement of resources with talents ranging from IT and finance to the executive level. Lastly, Protect prides itself in being an integral part of the community through its Protect Cares initiatives, supporting organizations like the Boys and Girls Clubs of Memphis, Streets Ministries, St. Jude, and the National Civil Rights Museum, to name a few. It's within our core values to be a true technology partner and help organizations leverage technology to achieve profitability, growth, and security. Today, we're excited to have Joe Webb with the SERO Group with us to discuss auditing data access in your SQL Server. Joe?
All right, thank you guys. Let's see here, let me advance. So today what we're going to talk about is who, what, and how auditing, although I just noticed there's a typo in auditing, data access in your Microsoft SQL Server. So as we begin to talk about this today, there are a lot of organizations that are, becoming more and more reliant on Microsoft SQL Server to manage their information. There are healthcare companies, they're relying on EMR and EHR systems, practice management systems. Transportation companies are increasingly becoming data-driven. Legal, banking, import-export, construction companies, all of them have this incredibly important information stored in their Microsoft SQL servers. And it is imperative to these organizations to be able to protect that data, make it accessible when they need it, make it resilient and reliable and perform it. And so today what we'll do is we'll talk about that, a way to help protect your data by auditing data access to your SQL servers using 3 different mechanisms that are all built into Microsoft SQL Server. So I'm Joe Webb, and at the SERO Group, we've been helping organizations manage their information inside of SQL Server databases for almost 25 years now. We work with companies around the U.S. We've worked with some overseas even. And so we've been doing this a long time. Our swim lane is very narrow. We don't get into a lot of the things that what a traditional MSP would get into. What we do is we focus exclusively and explicitly on Microsoft SQL Server. We do that in a couple of different ways. We have a database as a service, a DBA as a service offering, and then also some SQL Server consulting. And we do SQL Server assessments where we kind of do a health check for you to see, how your SQL servers are configured. So let's talk about today's session, though. In today's session, really what I'd like to talk about is the three aspects of who, what, and how we can audit our Microsoft SQL Server databases. We'll start by talking about some of the common challenges and issues that we may face when we are, which is prompting us to audit those SQL Server databases. So, when we talk about security, one of the first things that comes to mind is phishing, data breaches, and ransomware. I was doing some research the other day and stumbled across some statistics that I found interesting. According to Statista, in last year, in 2020, there were 1,001 data breaches in the US, which exposed a little over 155 million records. And according to the FBI, we've lost companies last year lost a total of $4.2 billion due to ransomware. And that was because of almost 800,000 instances of ransomware. And so knowing who is accessing our information and how to protect our information becomes critical. Every day, it seems, we hear about another breach or another compromise, another ransomware, another attempt, if nothing else, for a compromised attack on an organization. Accidents happen. We want to protect ourselves from accidents. I saw just a little while ago, this morning, as a matter of fact, that a police, the police department in Dallas apparently lost 8 terabytes worth of data, criminal case data, because of a mistake made during a data migration. And so accidents happen. Knowing who has access and what level of access they have to your SQL Server data, your financial data, your case management data is incredibly important. We can things happen. Users or devs accidentally delete data. Maybe they weren't even supposed to. We've seen where PII has been accidentally released because someone wrote a query that joined tables that they shouldn't have had access to. And so fortunately, it was caught downstream, but initially it was accessed, put into a report, and almost sent out to places where it shouldn't have gone. Additionally, a lot of times vendors will set up applications and databases for organizations, and when they do that, they almost always put themselves and require that they have sysadmin level privileges on the servers. And so that may be okay in your organization. It may not be okay. It depends on your situation and how segmented you have your databases. But knowing who has what level of access becomes incredibly important. There are also compliance issues to deal with, SOC 2, Type 1 and Type 2 compliance issues that can become something that you need to manage, knowing when a sysadmin was added, knowing when someone accessed this data, knowing when a user account was disabled. That becomes incredibly important during auditing and compliance issues. So let's talk about the first level, which is who has access to the information inside your database. And we'll talk about SQL Server security. So within SQL Server, we really have a couple of core concepts. Let's start with that. In SQL Server, we have the concept of authorization versus authentication. Authentication is essentially verifying that the person who's trying to connect, or the service account that's trying to connect to the SQL Server instance, is who they say they are. So when I log on to someone's SQL Server, that SQL Server needs to know that I am who I say I am. And then once I can connect, and that's the authentication component. Once I can connect, then we have to go down to the next level, which is authorization. Once I've connected, what do I have access to do? Can I get to this database? Can I read this table? Can I add new users? Can I drop users? Can I add myself to a different group inside of SQL Server or to a different role? So the concept of authentication, who can connect to the SQL Server, and then authorization, what can they do once they get there? We want to be able to manage and audit both of those. Now, inside of SQL Server, we can manage authentication a couple of different ways. We can have Windows authentication or SQL Server authentication. It's important to understand how your users are authenticating. If they're integrated into your Windows domain, that's great. That's a very secure way to do it. It's not always possible. Organizations may not have a Windows domain. You may have a SQL Server in a DMZ that doesn't have connectivity back to the domain for some reason. You may have other restrictions or requirements that are preventing you from using Windows authentication. And so SQL Server has built-in authentication capabilities. We can pass in a user ID and password inside of SQL Server, and it will authenticate to make sure we are who we say we are. And that's important to understand that, because we can turn on password complexity requirements and policy requirements inside of SQL Server, but we also need to manage that because some users can opt out of that. And then logins are essentially the way SQL Server allows a connection to the instance, and then the users are inside of a database. So SQL Server, like a lot of software that needs to deal with user accounts and permissions, uses role-based security. And really, we have three different types of roles inside of SQL Server. We have fixed server roles, fixed database roles, and database roles that we can create. The fixed server roles are things like sysadmin, server admin, security admin. There's some others, there's setup admin, and so forth, that have elevated permissions for the SQL Server itself. It's important to understand who is a member of each of those roles and when someone was added or removed from those roles. Fixed database roles, similarly, are scoped to the database level. Those can be things like who owns the database DB owner group, DB data reader and DB data writer. There are other groups as well, or other roles as well, and we can create our own specific roles to help us manage the security inside of a database. We could take it another level and assign permission outside of those fixed server roles in the database roles that we create. We can assign direct permission to users. That gets really complicated very, very quickly. We can also, SQL Server allows us to do row level security and even column level security. So we can grant different users access to different table objects or views at very granular levels. Again, that's really powerful, but it allows you to get very complex and unwieldily difficult to manage if you're not careful. However, we have seen that row level security in some instances is warranted. And we certainly want to adhere to the principle of least privilege. So when we assign a user to a particular role, we certainly don't want to grant them access to more than they need, or give them more power than they need, or more privileges than they need. And so within inside of SQL Server, we want to restrict or limit who has access to the data. Now, all of these, again, are available inside of Microsoft SQL Server, and you can look up using SP Help and some other queries that will show you who are the sysadmins on this server, who are the server admins, who has been assigned direct access, select, execute, something else to those database tables directly. And so we can track all of that information. We can query all of that information. And one last thing to be mindful of is you want to make sure that the service accounts used by SQL Server for both the database engine itself and for the scheduling agent, SQL agent, we want to also practice the principle of least privilege there as well. We want to make sure it's not that account is not a member of domain admins, or that account, if possible, should be a managed service account or a group managed service account within the Windows world. So again, I would encourage you to go and look at all of these fixed server roles. You can go into the Microsoft SQL Server, check those out to determine who has access to what level of authority and permissions within inside the SQL Server. All of that is built in and turned on by default. That allows us to see who has access at that moment in time. But let's talk about what data has been accessed. And that's where something called SQL Audit comes into play. So why do we care about SQL Audit? The SQL Server security, again, we can look at groups and see in the roles and see who has access to key resources. We can write the queries to determine who has access to this table or to this schema, to this database, to this instance. But that is oh, something happened. Can you hear me?
Yes, we can hear you now.
Okay. That information is current as of the moment that you investigate or look at it. So we can't really determine, based on the security roles, when someone was added to a particular role, when someone was removed, when someone was accessed a particular table. So sometimes that's not enough. When we need to look at auditing for compliance purposes, build that history of when data has been accessed, that information is just not sufficient. And so what we may want to know is when someone has been assigned to a security role, when a new security role has been created. We may want to know when a table has been created, or when someone inserted information into a table, or when that table had a row or two or 1,000 changed. And we want to know who had access to that. So with SQL Audit, that sort of information can be gathered. It allows us to specify key resources to audit, so we don't have to turn on SQL Audit for everything on the database. We can define specifically which resources we're interested in. We can define what changes are relevant for auditing. So do we care when someone inserts a new row into this table? Do we care when a user is dropped from a database? Do we care when other modifications have been made to role membership or when new roles were created? We could configure how long SQL Server is going to keep this recorded information. How relevant will this be? Do you need to go back 6 months? Do you need to go back 6 weeks? Do you need to be able to go back 6 days to investigate who has access to which information? And then further, we can go a step further and say, and tell SQL Server what happens if auditing is not available. If something happens, if a drive fills up, if something else breaks along the way, do we want to allow people to still interact with SQL Server, or do we want to pause the database or the server itself because auditing trumps data access? But it's important to understand that auditing, SQL Audit, is not configured or enabled by default. It's available inside of SQL Server, but it's not enabled by default. So unless you go in ahead of time and start capturing this information, it's not something that you'll be able to go back and say, something happened 6 weeks ago. Who had access to it? Who dropped this information? Who added this information? Who made these modifications? That's not going to be available to you unless you plan ahead and go ahead and enable the audit. SQL Audit has been around for quite some time. It was actually first introduced as an enterprise-only feature in SQL Server 2008. You could do both database audits and server audits back then. In 2012, Standard Edition allowed us to do the server audits, but we could not do database audits. It required enterprise for that. But in 2016, Microsoft realized this is really something that an organization, regardless of size, regardless of the depths of their pockets, should and does need to be able to do. And so in 2016, Standard Edition gained the capability to provide the server level audits and the database specific audits. So a server audit allows us to really create and define the key components of the audit, where the information is going to be stored, and what to do if the audit fails. We have some places where we can store this information. We could store it in the application log within Windows. We could store it in the security log within Windows, within the Windows server. We can also store it in binary files there on a C or D or E drive, something like that as well. And so we can capture this information. It's not logged to a table itself, but is stored outside of SQL Server. So server audits are things like when a principal has been changed. So a principal is really an entity within SQL Server. You could think of it as either a user account or a logon, something like that. So if you want to know when a new user has been created in a database, or when a new logon has been created for the instance, when someone has been added to the system's admin role, when someone has been removed from that role, so that we can track those changes along the way. What it's really designed to help with is that point in time snapshot that is insufficient for auditing. You know, if you want to look every 6 months to see who is your sysadmin, well, a bunch of people could have been added and removed from that sysadmin role during that last 6 months. This tracks every audit, or I'm sorry, every add or remove from that role. We can track other things as well. the logins that were created. We could track when modifications were made to the configuration of SQL Server. A ton of information can be captured at the server level. And within the database, we can also get down very granular as well. We can see when someone has been granted access to a table, when they've been denied access, or the grant has been revoked for that person. We could see when the database role memberships have changed, when someone's been added to a database role or removed. And we can go a step further and actually look at specific tables to see when someone has inserted data, when they've updated that data, when they've reported or selected from that table, or when a delete has been made on that table. And so it can get really granular in terms of the access. Some organizations, and we've helped some organizations, use SQL Audit to determine if people are still using this database. They've recently discovered a SQL Server. They want to sunset that SQL Server or consolidate it into another SQL Server so that they can reduce the number of SQL servers in their environment. But they're not sure if this database is even in use anymore. And so we can set up a SQL Audit on that database to see when someone accesses it, determine if that database is being used, determine if that instance is even being used anymore. So here's some examples of what we can query through SQL Audit. So at a server level, you can see here, this is a report that I've created using using SQL Audit at the server level, and this is a query that I've written. SQL Audit makes the information in the binary files available through a function that it exposes to us, so that we can query that binary file as if it's a table. We can then actually even join it to other tables where it becomes if that becomes needed. So you can see here that I was tracking the create of a new login, and at a specific time on Valentine's Day 2020, a login named JWeb Test 1 was created. JWeb Test 3, the login, was disabled. JWeb Test 2 was added twice to the sysadmin role. And then another login, JWeb Test 3, was created as well. And so you could see and track all of this information. We can also do it at the database level as well. You can see here that inside of this database, there is a table named product, and working from the bottom to the top here, you can see some inserts were made, and you can see the SQL statements that were used to create those inserts. You can see some select statements were issued, and then some update statements were issued. And so we can see the exact access to that table, to the product table in this case, and whether or not, and the SQL statement that was used to initiate that. One thing that is not captured though here is the before and after of an update. So we can see that an insert was created, or issued. We can see a select statement was initiated. We can also see that updates were created, and we see the SQL statement, but we can't not necessarily see what changes were made because of that update statement. We can't see, for example, which rows, how many rows were deleted because of that SQL statement. And so at times we may need to go a little bit further, and that's where change data capture can come in. So as I mentioned, SQL Server Security can determine who has access. Audit can determine when and how changes were made. But if you need to capture additional information, what changes were made, and how is the data after the change compared to the before the change? To get to that level, we have to use change data capture. Change data capture records all inserts, updates, and delete activity that is applied to one or more tables that we specify ahead of time that we're interested in. That data is stored in what's called change tables that mirror the source tables. And so if we're interested in a table for a specific application, we can target that table to be part of change data capture, and it will create another change table inside the same database that will where all changes are written. So if a record is changed for whatever reason, if it's inserted, if it's deleted, if it's updated from one value to another, that information is written inside the change table. Change data capture was created by Microsoft to help for analytics loads. So when you're creating a data warehouse scenario, for example, being able to tell what rows have been modified and how have they been modified so that you can import those rows or transmit those changes into a data warehouse can become a very complex task, particularly if you're doing hard deletes. Hard deletes meaning that we're actually removing a row from a table. Since the row's gone, propagating that row, or the deletion of that row to a data warehouse can be a very complex thing to try to do. Same thing for changes for adds and deletes even. And so, I'm sorry, updates even. And so being able to capture the information that was changed and being able to report on it from a specific table is really, really helpful in that data analytics migrations, those ETL processes. Like SQL Audit, change data capture is not turned on by default. If this is something that we want to make use of, we have to turn this on and configure it ahead of time. But it is available in both 2019's Enterprise and Standard Edition, but it should be used with a big caveat because these change tables are created inside the existing database. So they're created side by side with the original table. So if you have a table called production, or you have a table called activity or something else, a separate change table is going to be created side by side with it. That change table is going to be written to by changes from the original table. So those changes will be added to that change table, and you'll be able to report on that. But since it is a modification to the schema of an existing table, sometimes third-party vendors become very apprehensive when you do that. You may actually even break some of their supportability or their warranties that they provide. So you definitely don't want to turn this on for, say, a purchased application if you're using SAP or PeopleSoft or an EMR or something like that. This is not something you want to turn on without talking to your vendor first. But let's look and see how the change data capture process works from a high level. So when a source table is changed in some way, data is written to it, data is read from, or I'm sorry, updated, data is deleted from it. That information, based on Microsoft SQL Server's normal processing, that information is first written to the transaction log. So when a transaction starts, SQL Server immediately writes it to the log file. Then data is modified in the buffer inside of SQL Server. The buffer is another name for memory. It's modified inside the memory. Once that information then has been committed and all the change has been made, that information, that transaction is written to the transaction log as being complete. SQL Server will then at some point write the data back to the data file. The log file inside of SQL Server is critical because it's written to immediately and will help protect and make things make the database resilient in case power goes out, something else. So the source table writes the change to the transaction log. What change data capture does is it's a separate service that runs, and that separate service it's done actually through some scheduled jobs inside the agent, but that will read the log file periodically, identify whether or not changes have been made inside the log file, and then we'll write that information back to the change tables. We can then use views or functions that are exposed within Microsoft SQL Server's change data capture to report on that information. This works well because what we could do is we can actually pause change data capture if we need to. All of that information is still going to be written to the transaction log. And then when we start the change data capture process again, it will actually go back through the transaction log and then write that information to the change tables. Now, one thing you'll notice here is, since change data capture is based on changes to the database, to the tables that we're interested in, it does not capture any information about select statements. It does not capture any information about meta changes in terms of additions or deletions to security objects, database roles, server level roles, things like that. It's only concerned about providing, making us aware of changes to the database tables themselves. So let's put it all together then. Server security is a great way, and I'd highly encourage you to manage your SQL Server data access using the database roles and server level roles that we have available to us. That's always available and can be used right out of the box. SQL Audit is a great way to see what has changed over time. So it's a great way to see when someone has accessed a table that we're interested in or made modifications to security roles, particularly in the case of compliance or auditing, where we have to prove that, for example, if we need to prove that someone left this role on a certain date, within so many days, their access to, or so many hours in some cases, their access to the database was updated. We may need to be able to do that, particularly for SOC compliance. Page data capture may be used if you need to see how the data has been changed over time. So we can use these three in conjunction with one another, in concert with one another, to provide that broader perspective. So we have some additional resources here. Who has access? Who has sysadmin access to your SQL servers? What takes precedence when two roles conflict? If someone is granted access to a table and they've also been denied access to the same table through the same role or a different role, which one takes precedent? Who the DBO is, the database owner is, and what do you need to do if you want to change it? What's the best practice for who that is? There's some others up here: securing your SQL servers. What should you audit? Protecting your SQL Server from other from malware attacks, and using some scripts to identify if you've been exposed to attacks like Vulgar. So next steps from here, I would encourage you to examine your SQL servers for security best practices. Check your fixed server roles, see who are members of those roles. You could do this through scripts. If you want some scripts, I'll be glad to email them to you. I've got a bunch on the website. You can also just simply go into Management Studio and drill down into the security mechanism at the SQL Server instance level or at the database level to see who are members of those roles. You can also run scripts to check who has directly assigned permissions to various tables outside of the roles. And then I would encourage you to verify and make sure that if you're using SQL authentication for any reason at all, that you turn on password policy requirements so that the users will have to change their password on a regular basis. And it'll have to adhere to the Windows-based standard for the complexity of the password. Once you ensure that your servers are adhering to some of the security best practices, and this is the bare minimum here, I would encourage you to then start by identifying the level of auditing that's required by regulation of your business or by the stakeholders of your business, the business owners of the organization, to determine what level of auditing do you need. Once you understand the level, the gold standard for your organization, assess where you are, determine where your current state is. Can you audit to the level that the organization needs you to audit? And then develop an implementation plan to close the gap, to get you to the end state. Very likely won't be a short implementation plan. It may take you a little bit of time to figure out and implement it, but certainly take steps to begin closing the gap there. Create a test environment so that you have an understanding of how this may affect users. Once you implement auditing and once you do make some of these changes at the security level, you don't want to be surprised in the production environment. So create a test environment. Implement SQL Audit if you need to, and see how that's going to affect performance. And then test and monitor. Make sure that you're able to capture the information that you need to be able to report on for those auditing to your stakeholders, to your internal auditors, to your external auditors, and to make sure that you have a good understanding for your own benefit